All right, everyone, buckle up. We're about to take a deep dive into a topic that's absolutely crucial for anyone involved with cranes. You know, when those massive machines are working around power lines,
It can get pretty intense.
you got that right. Whether you're a safety pro, an operator, or just starting out and dreaming of that crane cab, this deep dive is for you. We're tackling OSHA's 1926.1408 standard. Think of it as the rule book for preventing those steel arms from tangling with invisible lines of energy.
Yeah, because we're not just talking about sparks and a light show here. This stuff is serious.
Exactly. It's high stakes, and that's why we're digging into the practical knowledge you need to make smart decisions out there on the job. OSHA starts by laying down the law with this idea of a work zone. Sounds pretty basic, but I'm guessing it's a lot more than just where the crane is.
You're right. It's about setting those boundaries before you even think about lifting anything. Picture it, you've got a massive crane coming in and power lines are everywhere.
Yeah, those things are like snakes in the grass sometimes.
Totally. So first, you got to figure out your safe zone. Where can that crane move? And where are the absolute no-go zones? OSHA gives you two ways to figure that out. First, you can mark those boundaries, with flags or devices that limit the crane's range. Or you define the work zone as the maximum reach of that crane, whichever keeps things safer.
So it's about knowing your limits before you even fire up that engine. Okay, so the work zone is set. We know where we can and can't swing that boom. What's next on OSHA's safety checklist?
Now the big question, how are we going to maneuver around those power lines? OSHA lays out three options, and it's pretty interesting how they approach this whole thing.
All right, let's hear it. What's the safest way to navigate this high voltage situation?
The gold standard. No doubt it's de-energizing and grounding those lines. You get the utility company to shut off the power, and they actually ground those lines right there on site. No electricity, no hazard. Pretty simple.
Peace of mind for sure, but I'm guessing that's not always an option. Like on a busy construction site, you can't just flip a switch and shut everything down. What happens when you can't just de-energize those lines?
That's when we move to option 2, what we call the 20-foot rule. Imagine you're the crane operator and those power lines are like a roaring lion.
You gotta stay clear.
Exactly. You wouldn't want to get too close to that lion. Same logic here. You maintain a 20-foot clearance at all times between any part of the crane, the load, even those rigging lines and those power lines.
20 feet, got it. Easy enough to remember. But on a busy site, with that crane moving in every direction, how do you judge that buffer zone in real time?
Well, that takes some skill, for sure, and that's why OSHA doesn't stop there. Option 3 gets a bit more technical. They've got this thing called Table A. Basically, this table, it's right there in the OSHA standard, lists specific minimum distances, and those distances, they change depending on the voltage of the power line.
Makes sense. Higher voltage, bigger danger zone, right?
Yeah, exactly. Like you wouldn't stand as close to a lion as you would to a house cat. But here's the thing, even if you're using Table A, you still need a bunch of other safety measures. You got to make sure that crane stays away from those lines.
So it's not enough to just know the distance. You need a solid plan to keep that crane from getting too close. What does OSHA say about actually making that happen?
Well, communication is key. Before you even think about starting that crane, there needs to be a meeting. The operator, the crew, everybody involved. Everyone needs to be on the same page. They got to know where those power lines are and how they're going to keep that crane out of trouble.
Yeah, no room for guessing games on a job site like that.
Yeah.
It's a team effort right from the get-go. So what else does OSHA require, to keep those close encounters to a minimum?
Now, this is where things get interesting, especially for those of you who like your gadgets and tech. OSHA mandates some pretty specific measures, some old school, some high tech, but all with the same goal. Keeping that crane far, far away from those power lines.
All right, I'm all ears. What's the first line of defense in this high-voltage standoff?
One thing OSHA's really strict about is using non-conductive taglines. Think about it. You definitely don't want to create a path for electricity to zap from the power line right to the crane or the load. That would be a disaster.
Definitely not the kind of fireworks we're looking for on a construction site. What else is there?
Then you've got the visual stuff, barriers and warnings. Think about those bright flags on the lines, really marking out that no-go zone for the crane operator. It's a simple reminder, but it's effective.
Simple and effective. Can't argue with that. What about the high-tech solutions you mentioned earlier? How's technology helping to boost safety around those power lines?
Technology is making a big difference here. OSHA specifically talks about 4 tech-based measures that can really ramp up the safety factor.
Okay, this is what I'm talking about. I love how technology is becoming a bigger part of safety these days. Tell me more. What kind of tech are we talking about here?
Well, for one, there are proximity alarms. You know those backup sensors on your car that beep when you're getting too close to something? Imagine that, but for power lines. If the crane gets too close, the alarm goes off warning everybody.
Like a little safety beeper for a giant crane. I like it. What else is there?
Then you've got the dedicated spotter. Their job is to be the eyes on the ground, watching the crane's every move, making sure it stays out of trouble.
An extra set of eyes focused on safety. Got it. What are those other two tech-based measures OSHA talks about?
Now, this is where it gets really cool. We're talking tech that can actually warn the operator or even limit the crane's movements. Like imagine a system that literally stops the crane from getting too close to those lines. That's what these automatic warning and range limiting devices can do.
Wow, that's incredible. So technology can actually step in and prevent those accidents. What's the fourth tech measure?
The fourth one is called an insulating link, or device. It's this special piece of equipment that gets installed between the load line and the load itself. It's like a barrier against the flow of electricity.
A safety net, just in case everything else fails.
You got it. It's all about creating multiple layers of protection.
Okay, so we've got planning, those non-conductive taglines, visual cues, and this whole arsenal of tech solutions. OSHA is definitely taking a multi-pronged approach here.
Yeah.
But this is just the beginning, right? There's more to keeping crane operations safe around power lines.
You're absolutely right. We've just scratched the surface. We haven't even gotten to the stricter rules that apply when you're working below those lines, or the importance of training.
Okay, I'm ready for more. We'll delve into all of that and more in the next part of our deep dive. Stay tuned.
Welcome back to our deep dive, folks. We're getting into some even stricter rules now, for operating right under those live power lines.
Okay, yeah, things are getting serious. We talked about keeping our distance, but what happens when you absolutely have you out to work directly under those lines?
Well, OSHA's pretty clear about that. You don't. Working under those lines with any part of the crane, the rigging, the load, it's a big no-no.
So no exceptions.
There are a few, but they're very specific, and they all come down to one thing: getting rid of that electrical hazard. The line has to be de-energized and visibly grounded. No compromises there.
It's like a surgeon going into surgery.
Yeah.
You wouldn't start cutting until everything was sterile.
Exactly. But even with those exceptions, you got to be extra careful. You've got gravity, heavy loads, potentially other live lines nearby. It's not a place for mistakes.
Right. Even if the line's right above you or off, there could be others that are still live. You need to be aware of everything around you. Okay, so we've got the rules for working near power lines and the even stricter ones for working below them. But rules are only as good as the people following them. And that's where training comes in, right?
Absolutely. Training's essential, especially for the people operating those massive machines. And not just the operators, the whole crew. OSHA's very clear about that everyone needs comprehensive training.
You keep saying comprehensive training, but what does that actually look like? What do they need to know that could really save their lives?
Well, first off, everyone needs to know exactly what to do if there's electrical contact. It's like emergency response, but specifically for working around power lines.
Because in that kind of situation, knowing how to react quickly could make all the difference.
Exactly. The training needs to cover the dangers of touching the equipment and the ground at the same time, why staying inside the cab is usually the safest option, and the best ways to get out of that energized equipment if you need to.
So it's not just about individual safety, it's about protecting the whole team. Which brings us back to that idea of step potential.
Right. You got it. Training on step potential is crucial. People need to understand that the ground itself can become energized near that point of contact.
Yeah.
So even if you're not touching the line or the equipment directly, you could still be in danger.
Like an invisible danger zone. So everyone needs to be aware of that, not just the operator. What else does OSHA want people to know?
Another big one is the assume it's live mindset. No guessing, no taking chances. Treat every power line like it's buzzing with electricity.
Makes sense. Because even if a line looks dead, there's always a chance it could be live. Better safe than sorry.
Exactly. And speaking of things that can be misleading, the training also needs to cover the limits of those safety devices. Proximity alarms, insulating links, all those things are great tools, but they're not foolproof.
So it's about using technology wisely, but not relying on it completely.
Right. Human judgment and awareness are still super important. And finally, the training needs to cover how to ground equipment properly and when grounding might not work. It's a key safety measure, but it has to be done right, and people need to know when it's effective and when it's not.
Okay, so to recap, OSHA wants training to cover emergency response, understanding that step potential, assuming lines are live, knowing the limits of those safety devices, and proper grounding. It's all about giving people the knowledge to make smart decisions and stay safe.
That's a great summary. And it's not just a one-time thing. This training needs to be ongoing with refresher courses and updates as needed. The goal is to create a culture of safety where everyone's always learning and adapting.
Speaking of adapting, I'm curious about different types of cranes. Does the type of crane change those safety procedures?
That's a great question. The basic principles of safety are the same. Electricity doesn't care if it's a tower crane or a mobile crane. But certain cranes do bring their own challenges.
I'm thinking about those cranes with booms that can extend and move in all sorts of directions. That seems like it could make it easier to get too close to those lines.
You're right. Those dynamic booms can be tricky. You need to be extra aware of where that boom is and where it could reach, no matter how it's moving.
It's like a dance where everyone needs to be in sync, watching each other and staying clear of those lines.
Exactly. It's all about teamwork, with safety as the #1 priority. And speaking of teamwork, what about the safety professional or the site supervisor? They're not the ones operating the crane, but I bet they play a big role in keeping things safe.
Absolutely. They're like the conductors of this safety orchestra, making sure everyone's playing their part correctly. They're the ones running those pre-work meetings, checking the equipment, and overseeing everything.
Right. They're not just enforcing the rules, they're setting the tone for the whole job site. Their leadership is crucial for building that culture of safety. But it's not just about the people on the construction site, right? The utility company that owns those power lines has a role to play too, don't they?
Yeah, good point. I mean, it's their equipment after all.
Absolutely. OSHA specifically mentions the utility company a few times in the standard. For example, if the employer wants to de-energize and ground those lines, they need to get confirmation from the utility company that it's been done and that those lines are visibly grounded at the worksite.
So there needs to be clear communication between the employer and the utility company, with no room for misunderstandings. It's a shared responsibility.
Exactly. And that communication needs to be documented too. The employer needs written confirmation from the utility company. That way there's a record of who's responsible for what and everyone's on the same page.
Paperwork might not be exciting, but it can be important in these situations. What about when you can't de-energize those lines? Does the utility company still have a role?
They do, especially when it comes to using Table A, those voltage-specific clearance distances. If the employer doesn't know the voltage of the power lines, they need to ask the utility company for that information.
So the utility company needs to be responsive and provide that information quickly. I can imagine it could be a challenge, especially on a site with lots of different power lines.
It can be. That's why OSHA has a rule that the utility company has to provide that voltage information within 2 working days of the request.
Okay, 2 working days. That gives them time to get the information, but it doesn't hold up the project for too long. I'm noticing a pattern here. Communication, coordination, collaboration, it all seems crucial for keeping everyone safe when cranes are working around power lines.
You're absolutely right. It's not just about following the rules word for word. It's about creating that culture where everyone talks to each other, shares information, and works together to minimize those risks. It's all about making sure everyone goes home safe.
Well said. We've covered a lot in the second part of our deep dive, but there's one more thing I want to talk about before we wrap up. Something especially relevant for those aspiring crane operators and those who train them.
Sounds interesting. What is it?
I'm really fascinated by those simulators and virtual reality training programs, for preparing operators for those dangerous situations around power lines. It seems like a safe way to practice making those critical decisions. What are your thoughts on that?
That's a great point, and it's something that's becoming more common in crane safety training. Simulators and VR have come a long way. They offer some real advantages when it comes to getting operators ready for the real world.
What kind of advantages?
Well, they can really mimic those visual cues and that sense of scale you get when you're operating a crane near power lines. Operators can practice keeping their distance, reacting to close calls, all in a safe virtual world.
Like a test run, but without the real-world consequences.
Exactly. And because those simulations are so realistic, they can even trigger those physical reactions you get in stressful situations. Increased heart rate, tunnel vision. Trainers can see how operators react under pressure and give them feedback.
It's like a dress rehearsal for a high-stakes performance. They can make mistakes and learn from them without putting anyone in danger. What about those unexpected things that happen on a real job site? Can simulators handle that too?
To a certain extent, yeah. They can simulate things like wind, uneven ground, obstacles. But of course, there are limits. They can't perfectly replicate the feeling of actually operating a crane or all the unpredictable things that can happen in the real world.
Right. So while they're a great tool for training, they can't replace real-world experience.
That's right. They're a great way to enhance learning, but not a replacement for the real thing.
Okay, I think that's a good place to stop for now. We've talked about a lot today, from those extra strict rules for working below power lines to all the details of OSHA's training requirements. And we even got into those cool simulators and VR training programs.
It's been a great discussion. I hope everyone listening is feeling more informed and ready to handle those tricky situations around power lines.
Me too. But we're not quite finished yet. In the final part of our deep dive, we're going to look at some real-life examples, stories about things that went right, and unfortunately, some where things went terribly wrong. It's a way to see all this stuff in action.
I agree. Those real-world stories are powerful reminders of why all this matters. They show the human side of these safety measures.
Everyone stay tuned for the final part of our deep dive. We'll be back soon. All right, welcome back everyone for the final part of our deep dive into crane safety around power lines. We spent the last two parts digging into all those OSHA regulations, all those rules and requirements. But now it's story time. We're going to look at some real-world examples. You know, those moments where everything went right and, well, those moments where things took a turn for the worse.
Yeah, because sometimes those regulations can seem kind of dry until you see how they play out in real life. Looking at what actually happened, both the good and the bad, can really show you why safety matters.
Okay, so let's get into those case studies. Have you seen any examples where those layers of protection we talked about, the procedures, the technology, all came together and actually prevented a major accident?
Oh, absolutely. One that comes to mind was a bridge construction project. They had a crane working near a high-voltage transmission line.
That's a pretty intense situation right there.
Yeah, no kidding. But they had a really detailed lift plan, a dedicated spotter, proximity alarms on the crane, non-conductive taglines. I mean, they were doing everything by the book.
Sounds like they were taking all the right precautions, but something still went wrong.
Well, not exactly wrong, more like a close call. As they were lifting this massive steel beam, a gust of wind caught the load and swung it a bit off course.
Oh man, that's too close for comfort when you're talking about high voltage lines.
It was a tense moment for sure, but that's when the proximity alarm went off. It alerted the operator and the spotter that the load was getting way too close to the power line.
So the alarm did its job, but I bet that took some quick thinking on the operator's part too.
Absolutely. The operator reacted immediately, stopped the lift, and slowly moved that load away from the line. It was textbook stuff.
So technology provided that warning, but it was the operator's training and skills that prevented a disaster.
Exactly. They knew what to do in that situation and kept their cool under pressure. It could have been a really bad situation, you know, someone getting electrocuted, maybe even a power outage, but they avoided it.
It just shows how those layers of protection, the tech, and the human element can really work together to keep things safe.
Couldn't agree more. It's a great example of how vigilance and quick thinking are crucial, even with the best safety technology in the world.
All right, so that's a story with a good ending where a potential accident was prevented. But I know it doesn't always turn out that way. Have you seen cases where, despite the regulations and precautions, things still went tragically wrong?
Yeah, unfortunately I have. And those are the cases that we really need to learn from because they show what can happen when things break down.
I imagine those are the toughest ones to analyze because it's rarely just one thing that goes wrong.
You're right. It's usually a chain of events, a series of small mistakes that add up to a big problem.
Like a domino effect where one little thing leads to another and then another until.
Exactly. It can be really hard to pinpoint one single cause. Do you want to hear about a case that really shows how this can happen?
I do. I know you might not be able to share all the details, but I think hearing about those real-world scenarios can be a powerful learning experience for everyone listening.
Okay, there's one that comes to mind. It involved a tower crane being used to build a high-rise. The crane was near power lines, but the crew had been working there for weeks without any problems. They were following all the rules.
Sounds like they had a good system in place. So what went wrong?
Well, on this particular day, they had to change the plan a bit. They needed to lift a load to a higher floor, which meant extending the crane's boom further than usual.
Oh, I see where this is going. That changes the whole dynamic, right? Suddenly they're closer to those power lines.
Exactly. And unfortunately, someone dropped the ball on communication. The operator wasn't fully informed about the new plan or how much further that boom was going to reach.
So a critical piece of information wasn't passed along. What happened next?
Well, as the operator was extending the boom, it hit those power lines. The crane became energized and the operator was electrocuted.
Oh, that's terrible. And it sounds like it all could have been prevented with better communication.
That's the hard lesson we learn from these accidents. Even with experienced people, careful planning, and the right equipment, a simple miscommunication can have devastating consequences.
It's a stark reminder that safety can never be taken for granted. It's an ongoing process, a team effort, a responsibility that everyone shares.
Exactly. Complacency can be the biggest danger in a high-risk job like this. Just because we've done something safely before doesn't mean it'll always be safe.
Well, these case studies have really brought home the importance of knowledge, awareness, and communication when it comes to crane safety around power lines. It's not just about following the rules, it's about creating a culture of safety. A culture where everyone feels comfortable speaking up, asking questions, and watching out for each other.
I couldn't have said it better myself. We need to build that environment where safety comes first, where shortcuts are unacceptable, and where complacency is recognized as the enemy.
To everyone listening, whether you're a seasoned safety pro, a crane operator, or just starting out in this field, remember, your knowledge, your awareness, and your commitment to safety can make all the difference. Stay informed, stay vigilant, and stay safe out there.
And never stop learning. This industry is always changing, and it's our job to keep up with those changes and share what we know with others.
Well said. Thanks for joining us on this deep dive into crane safety around power lines. It's been a sobering but hopefully empowering look at a topic that's so important for everyone in this industry.